Hey everyone, welcome to our test review Minecraft edition. Today we're going to discuss several things to help you review for your test. First being mean, median, mode, and range. Then we're going to talk about mean absolute deviation. And finally, we're going to review box plots, dot plots, and histograms. First up, mean, median, mode, and range. As you can see here, I am showing you the different amount of diamond in different player inventories. The first question I'm going to ask you is, what is the mean number of diamonds in these players' inventories? So remember, the first step to finding the mean is to add all of the numbers together. If you do that and you add the 7 plus 12, 9, 9 plus 12 plus 64, you add all those together, you're going to see that that total is 133. When you take your test, remember, it is okay if you use your calculator. I am not going to consider that cheating on this. I want to know that you know how to find each one of these particular parts of the data. Now, the next step in finding the mean is to take that 133, which is the sum of our numbers, and divide it by the amount of numbers that I have. I have 1, 2, 3, 4, 5, 6, 7 different players we're talking about. So I'm going to divide 133 by 7, which again, if you want to use your calculator, feel free. And you're going to see that the mean for this set of data is 19. Question number 2, what is the median number of diamonds in these players' inventories? Well, I hope you remember your first step to find the median is that you must put the numbers in order and find the middle. So here are those numbers in order. To find the one in the middle, I'm going to cross off numbers from each side as I go to see that my median is 12. My next question for you is, what is the mode? Now, it is okay to have more than one mode. You just need to remember that the mode is the number or numbers that show up the most. So if you look at your data, it's usually easiest to look at the numbers in order. You're going to see that we have 2 number 9s and 2 number 12s. So both of those would be our mode, 9 and 12. Next question and final one on this slide, what is the range? I'm asking you to find the range. You need to remember that the range is when you subtract the smallest number from the biggest number. And in this case, our biggest number was 64 and our smallest number was 7 to get a range of 57. Something I want you to note, the number 64 here is quite larger than the rest of the terms in this data set. When that happens, 64 would be considered what we call an outlier. It's whenever you have a number that is way bigger or way smaller than the rest of your data. Right, next slide. Mean absolute deviation. We're going to use the same set of data that we had on the previous slide. So I hope you remember that our mean was 19. We already found that. Now, what do we need to do in order to find the mean absolute deviation? Well, what you're essentially doing is creating a new set of data by calculating how far each number is away from the mean, and you're going to do that by simply subtracting. So I'm going to first look at number 7. To see how far away it is from the mean, all I need to do is 19 minus 7, and you're going to see that that equals 12. So that's the first number in my set now. The next number, 9, to figure out how far away it is from the mean, I'm going to do 19 minus 9, which gives me 10. So this second 9 is also 10 away. 12, if I do the subtraction, 19 minus 12, that's going to give me 7. So both of these 12s are 7 away. I know that 20 is only 1 away from 19. And then 64 minus 19, if you do that math, you're going to see that it is 45 away from the mean. That's because 64 is an outlier. Now, the next step is to find the mean of that new set of numbers. So we're looking now at this set of numbers we just created that I'm circling here, 12, 10, 10, 7, 7, 1, and 45. You're now going to find the mean of that set of data. As we discussed on the previous slide, to find the mean, you need to add all those numbers together, which would give you 92, and then divide by the number of terms that you have. It is important that if you started with 7 terms in your first set, that you should still have 7 terms in your next set, which we do. So to find the mean of that set of data, you would divide to see that the mean absolute deviation was 13.142. It kept going. But let's say I asked you to round that to the nearest hundredth. So I'm going to look and see this 4 is in the hundredths place. I'm going to look to the number behind it, and that 2 is not big enough to make it round up. So if I rounded this to the nearest hundredth, the mean absolute deviation would be 13.14. And that would be my mean absolute deviation. That's a pretty big mean absolute deviation. And the reason for that is because we had this outlier, 64. 64 makes those numbers a lot more spread apart. If you eliminated that number from the set, they would be a lot closer together. Dot plots. On this slide, we're going to review what you can do with a dot plot. The one you see in front of you represents the hours that students spent playing Minecraft this week. The first question I'm going to pose is, how many students did Mrs. Riphand survey? So if you wanted to answer the question of how many students I surveyed, you could do that in 2 ways. You could count each individual dot one at a time, 1, 2, 3, and go all the way through. Or you could count each number at a time, like there's 6 students at 0, 2 at 1, 3 at 2, 5 at 3, and you could do this for your whole list, and then just add those numbers together. You could actually do both ways just to double check yourself. Either way, if you do this and you add all of those numbers together, you're going to see that I surveyed 40 different students. Question number 2. What was the median number of hours spent playing Minecraft? So, because I know that I surveyed 40 students, I know that there's going to be 20 on either side of this data. So this makes it go a little bit quicker than simply crossing off as you go, which is another method. But if I get rid of 6 students over here, so use my highlighter, here's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's half of the data. And I'm going to use another color to show you that it's going to get me right to the middle. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We're going to have to jump all the way over here. 18, 19, 20. So the middle point of this data is right here. Because that falls on the number 5, the median of this data is 5. That meant that the median amount of hours spent playing Minecraft for this particular week was 5 hours. Question number 3, how many students played less than 4 hours of Minecraft this week? Let me erase some of this data for you. So now if I want to look at my dot plot, I can see if I'm looking for how many students played less than 4 hours, I got to find where 4 is, which is here. These students here played less than 4 hours this week. So I just need to add those numbers together. This was 6, 2, 3, and 5. So 6 plus 2 is 8, plus another 3 is 11, plus 5 is 16. The answer to that would be 16 students played less than 4 hours of Minecraft this week. Another way to represent data is called a box plot. This particular box plot represents the amount of gold in different player inventories. Something you cannot tell by looking at a box plot is how many players, or whatever the data is you're talking about, how many players I observed, because this does not tell you anything about specifics. It only tells you the measures of variation. What you can tell from a box plot is all of these pieces of information: the lower extreme, the lower quartile, the median, the upper quartile, the upper extreme, and the interquartile range. All of those besides the interquartile range you can simply find by looking at your box plot. So let's do that. The lower extreme is simply a fancy way for saying the lowest number on the box plot. So this end of our whisker here, this represents our lower extreme. It's simply 42. Moving a little bit over, if we're looking here at the lower quartile, that number represents the median of our lower half of data, and that is represented by this end of our box. So the left end of the box represents your lower quartile. In this case, is represented by 48. The median of a box plot is always the line inside of the box. In this case, it's represented by 52. The upper quartile is the right side of your box, which is 58, and that represents the median of our upper half of data. So that's 58. The upper extreme is simply the highest number on our box plot. In this case, it's 66. And the only math you would have to do to find the interquartile range, you need to subtract the upper quartile, which was 58, and subtract from that the lower quartile, which was 48. So the interquartile range here would simply be 58 minus 48, which would give you an interquartile range of 10. You will also, on your test, have to be able to take a set of data and turn it into a box plot. You're not going to actually have to draw it, but you're going to have to choose from a multiple choice list which box plot represents the data. Remember, to find these pieces of information, you're really just finding the median 3 times. And if you need to review that, please go back to the box plot video that I have on our Edmodo page. All right, another question that you may see about box plots is something that deals with percents. So the percent of data in each part of a box plot is represented by 25%. This first part here, from the lower extreme to the lower quartile, that's 25%. The lower quartile to the median is another 25%. The median to the upper quartile is another 25%. And the upper quartile to the upper extreme is also another 25%. Even if they look like one part is way bigger, for example, if this line went all the way down to here and the lower extreme was here, this part would still be 25% of your data. In this case, they all kind of look equal, but it doesn't matter. These pieces of information that we talked about in number 1 all deal with 25% of your data. So the question I asked in number 2 was, what percent of the data is between the lower and upper quartiles? So between the lower and upper quartiles means that we're dealing with the information in the entire box. Because this was our lower quartile on the lower side of my box, that's the lower quartile. This is the upper quartile. So the data between the lower and upper quartiles, which is our interquartile range, if I add 25 and 25 together, you should see that that is represented by 50% of your data. What is the range? The range in any graph that you're going to talk about deals with taking your biggest number and subtracting your smallest number from it. So 66 minus 52, your range is 14. The last data display that we're going to talk about is the histogram. This particular histogram talks about the amount of wood in players' inventory. So the only difference between a histogram and the bar graphs you have seen since elementary school is what I'm highlighting here at the bottom, which are called intervals. They have to be in order and they have to be equal. The other thing about a histogram is that these bars, which represent frequency, have to touch. If they don't touch, like you see here from 0 to 149, that means that there's no data there. So in this particular histogram, that means there were no players that had between 100 and 149 blocks of wood. So the questions that you might see asked, how many players have between 50 to 99 blocks of wood in their inventory? So all I need to do to figure this out is look back to the bar that's represented by that 50 to 99, and you can see that that bar has a frequency of 8. So the answer to that question would be 8. I may also ask you this question. How many players have more than 199 blocks of wood in their inventory? So for this now, I need to look and see, okay, 199 is here. These two bars represent people who have more than 199 blocks of wood in their inventory. And this first bar, that has a frequency of 4, and this bar has a frequency of 2. So if I add those two numbers together, I would say that there are 6 players that I surveyed that have more than 199 blocks of wood in their inventory. Another question you might see, what does the gap between 100 and 149 show? I already explained that to you. This gap here means that no players had between 100 and 149 blocks of wood in their inventory. And the very last question is, what is the range of this histogram? As we talked about on the previous slide, the range, no matter what type of data display we're looking at, always takes the largest number, which in this case is 299, and subtracts the smallest number, which in this case is 0. So that's easy for us, because 299 minus 0 means that our range for this set of data is simply 299. All right, again, if you have any more questions, please let me know. Study, study, study. Your test is on Monday.